So, hello everyone, how are you all? I hope you all are fine and safe. I'm back with another video and welcome you all to my channel Quantum Mathematics. I'm back with a generalization video. Like in this video, I'm just going to generalize an integral thoroughly. Basically, I'm going to generalize it with a function that is a random function. So it could be anything like trigonometric function or an algebraic function. It could be anything like an exponential function. So yeah, that's what I'm going to do, and it's not gonna be a easy looking integral, but it's gonna be a creep looking integral. I think it's up to you. You have to judge it out. Well, I cannot explain that to everything without writing it on board. So let me write it first. Well, that integral is, let's say that is I. So integral is the integral of f of x. As I told you to, I'm just going to like generalize it in terms of f of x only, right? Plus 1 over f of x plus 1 over f of x and plus dot 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 to infinity. Well, dx and dot 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 to infinity. That's it. So this is what we are going to generalize in today's video. Well, maybe for some viewers it's quite easy, but there are a lot of viewers who find difficulties after looking at it, because when you just plug some functions in this integral, it's gonna look so bad, so disgusting. Like, let me take an example. Let's talk about a function f of x. Let's introduce some functions in it. It could be like, let's say that or let's say some constants. So let's say that 5 over square root of 5x to the 4th plus x to the 6th. So yeah, when you plug this function inside this integral, so it's gonna look like something like this. Integral 5 over the square root of 5x to the 4th plus x to the 6th plus 1 over 5 over the square root of 5x to the 4th plus x to the 6th plus 1 over 5 over the square root of 5x and dot 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 to infinity. So somewhere it's literally looking like it's disgusting, right? So that is why for any kind of function, like it could be anything, as I said earlier in the beginning of this video, like it could be e to the x or sine x, cos x, x square, x to the 4, anything, right? So for all these functions, I'm just going to generalize this integral so that whenever you got this integral in your lifetime in future, so you don't need to just solve it thoroughly, but you can just plug it, or maybe you can just, if you like at first when you just have a look of this integral, at first you cannot find the way to solve because it's gonna look creepy, right? So at first maybe you got scared, but now I'm just going to generalize it, right? Okay. So how are we gonna do that? Firstly, let me tell you something. Well, I just wanna ask you. This is f of x plus 1 over f of x, right? Plus 1 over f of x, and that is going up to infinity, right? So the process is starting from f of x itself, and then the addition of a reciprocal of this f of x, and that goes up to. So maybe I can say this part as I itself, because it's representing the same stuff. When I'm sorry, actually integral and then integral. Yeah, I just messed up with that. I just got messed up with that. But now it is fulfilled actually. And now we can say that this is I, and that's how we're gonna just replace it with I. So that is gonna make our life easier. That is the integral of f of x plus 1 over I dx, right? So from this thing, like we have concluded to this thing, that is a quite good looking integral, that is a quite evaluable integral, I think. And now this is a constant, so let's just break this integral in two parts. So first part is integral f of x dx, and then 1 over I integral of dx. Basically it is integral f of x dx plus x over I, right? Yeah. So I am having x over I, an integral of this f of x, and then I'm having I. Well, x is a constant because it's not inside this integral, so I can just like subtract with x over I on both the sides. So what's that gonna give me? That is I minus x over I is the integral of f of x dx, right? Okay. So now I'm just going to I'm just going to multiply, like I'm just going to multiply with I and divide with I on both the sides. So that is gonna give me I squared minus x and I times the integral of f of x dx, right? Okay. So now we are just going to play with this integral, and now we are going to use uh, the quadratic formula or the quadratic method, or in Indian accent it is Sridharacharya's method, right? Okay, so what that says is x, if you are having x square, or let's say that a general quadratic equation ax square plus bx plus c equals 0, and a is not equal to 0 obviously. So for this you are having x equals minus b plus minus square root of b squared minus 4ac over 2a. So I just want you to remember this. Although we can, there are a lot of like quadratic equations and expressions that could be factored out with middle term splitting method, but again there are multiple exceptions which cannot be done by that method, so we have to go through this only, and that's how. So for this integral, or this for this expression, for this quadratic, I'm just going to use this method to evaluate a general like where here it is x but here it is I. So if I'm just plugging I over here and I'm just going to solve it along with the I, or taking the perspective of I, I'm just gonna have a general like value of pi, right? So that sorry, not pi but actually I. Okay, so I just want you to note that down. Please note that down, right? Okay. Now we can just write it down. Let me just write it down over here. We can write it down as I squared minus I times the integral of f of x dx, and then minus x equals 0. So this is what our general like quadratic equation that we have to deal with right now. So from our quadratic equation formula, I equals minus of, or maybe it is just plus integral f of x dx, okay, plus minus square root of the integral of f of x dx whole squared minus, or maybe plus 4x over. I hope you understand that how I'm just like changing the signs, because these two things are in negative terms, so I have to change it according to that. And then let me just write it down slightly lower here. Okay, and then in the denominator we are having only 2. So successfully we can say that, let me just, okay, so from here we can say that our I, or maybe that thing, that is the integral of f of x plus 1 over the integral of f of x actually dx, and plus 1 over the integral f of x dx. So this is being evaluated to the integral of f of x plus minus square root of the integral of f of x dx whole squared plus 4x over 2. So this is what the general representation of this like creepy looking integral. And we are not done yet. We have to just use it, or maybe we have to just apply it to get some good looking results. Like I'm just going to apply some functions in this equation. I'm just going to replace it with that, and then we'll see what we can get from that. Well, okay, so I just want you to note that down firstly, and then we'll begin with that. Okay, so I hope you must have noted down that. Now we are good to go with the second part. So let me just erase this stuff. Okay, so firstly I would like to take the very good or a very fascinating function, that is, first let's say that f of x equals e to the x. It's good because it is the only function. The integral of this function as well as the differentiation of this function is just that function, it is as it is. So yeah, it is really impressive. So now we're just going to replace f of x with e to the x in that equation. So how it goes: integral e to the x plus 1 over integral e to the x plus 1 over integral e to the x plus 1 over, and that is up to infinity. So dx. So on the right hand side, the integral of e to the x, then plus minus the square root of the integral of e to the x dx whole squared plus 4x over 2. Or maybe we can give some like limits after we calculate this part. So let me just first calculate this part, and then we'll give some limits to replace x. So how this goes is the integration of e to the x is just e to the x, and then plus minus the square root of the integration of e to the x is just e to the x. It means its square is e to the 2x plus 4x over 2. So this is what the integration of, like, this is being evaluated to, right? This is really amazing, I think. Yeah. So now we can just replace it with some values, like let's say that maybe we can put some values, or you can just do it by yourself. It's up to you that you can put anything right over there, like the limits of this integral. So you can just have a fun with that. But I think I should just stop right here, or maybe I should just place a c here and along with here also, right? Okay. And now if I want to play with some more functions, so let's play with another function, and that is, this is gonna be quite good, I think. So this is second one, f of x, let's say that is cosine of x, right? Okay, so now for this function you have to check the range and domain, actually more precisely, or the range of this function, and then only you can just apply the limits. So be careful that don't go beyond the like the range of this function, right? Okay, so the integral of cos x plus 1 over the integral of cosine of x dx, actually not dx here, actually plus 1 over integral cosine of x dx and dot to infinity. Wait a second, guys, let me just turn on my AC. Actually, I'm having some sort of problem. Okay. So this replace the right hand side with f of x with cosine of x, right? So integral of cosine of x plus minus the integral, the square root of the square of the integral of cos x dx actually whole squared and plus 4x over 2. So how this goes is the integral of cosine x is just sine x and plus minus the square root. The integral of cosine of x is sine x. It means that the square, it's gonna be sine squared x plus 4x and over 2. So this is what it is. And believe me guys, this is very easy to remember this. You just have to replace your b, like in the Dharacharyas or the quadratic formula. You just have to replace your b with the integral of f of x dx along with minus sign, obviously, to just neutralize here, as we saw in the formula. And your a is 1 and your c is just -1. So this is what it is all about. And from here you can just evaluate your I as minus of b plus minus the square root of b square minus 4ac over 2a. So these two things are required, that's it. And you can play with any function you want. You just have to replace these things with that. You just have to put these things into that, and you're gonna have the same result that I have evaluated. Isn't it easy? So that's it, guys. I think it's quite understood, and yep. So you can just have a lot of fun with that. You can just plug f of x equals maybe x square or maybe x cube or anything else, right? But be careful when you plug, when you want to play with some trig functions. So be careful about the range of that function, right? And then only you proceed with that. So I think for now it's enough, and I hope you had some fun with this. So just stay tuned for the next video. Thank you so much for watching this video. Goodbye.